Hello, everyone. Good morning, good afternoon. Thank you so much for joining today. My name is Claire Gandy. I'm the technical sales manager with the Dramix Steel Fiber Reinforcing Group at Beckart. And I'm here today just to welcome you and go over some kind of bookkeeping items before we'll turn it over to Danny and the bulk of our discussion about jointless floors. First of all, I do just want to say thank you so much for taking time out of your busy schedule to join us. We really do appreciate it. If you are having any kind of technical issues with watching or hearing this webinar, we do recommend using Google Chrome. If you're already using Chrome and you're having issues, just use the chat feature and let us know, and one of our moderators can help you troubleshoot. We will not be taking questions throughout the session. We'll hold our Q&A until the end, but as you have questions, please use the chat feature to go ahead and write those in, and then at the end, we'll go ahead and address those as much as we can, time permitting. If there are more questions, Danny will be able to follow up with those of you with outstanding questions. If any of you structural folks on the line would like a continuing ed credit, a PDH for today, please do email me or Danny, and we can go ahead and get you set up with that afterwards. All right, folks. Well, with that, let me go ahead and introduce our wonderful speaker today. Danny Godinez has about 5 million square feet of jointless floor experience. He's the person I go to with all of my questions about jointless floors. So he's really an experienced person to speak about this topic. And so with that, I'll pass it over to you, Danny.
Thank you, Claire. So let us go ahead and get started with the presentation. Again, as you think the questions, feel free to post them, and my information will be listed toward the end of the presentation. So when we're talking about steel fiber reinforced concrete, specifically jointless floors, there are four primary factors that owners or engineers tend to appreciate and understand the benefit of jointless floors when it comes to reinforcement with steel fibers. The first one is that we have an optimal load-bearing capacity, meaning that we don't have a sectional reinforcement. The reinforcement is throughout, top to bottom, side to side, which allow us to have a better crack control. Historically, by comparison to conventional systems, one of the additional benefits is that we have a high fatigue resistance. We don't have a cover of 1.5 or 2 inch of plain concrete. We have reinforcement very close to the surface and very close to the edges, which allows for better fatigue resistance, especially at the most painful areas, such as the saw cuts, control joints, or the edges of any condition. And the fourth one is we have a high impact resistance. That is a byproduct of our solution. By having steel very close to the surface, it allows us to account for those impacts, whether it be in a manufacturing facility or the forklifts bidding on the floor. There are probably four main characteristics that we like to make sure that is clearly understood by everybody. When we talk about steel fiber reinforced concrete and fiber specifically, the main differentiator for performance is going to be the aspect ratio, which is the length divided by the diameter. That is going to be the main performance variance for any steel fiber reinforced concrete, specifically when we talked about jointless floor. Having a good fiber is the key to success. But the key to success also come with the longer fibers, better tensile. So to ensure that you're going to have homogeneous distribution, that fiber has to be introduced as a glued, meaning in fingernail clips or clips on a nail gun, if you will. After 2 minutes of mixing time, the glue will dissolve and will allow the homogeneous distribution throughout. The third one is really a combination of tensile and anchorage mechanism, which we'll talk a little bit more here in a minute. So when we talk about jointless floors, the way to ensure performance, to control better cracking solution, is with a better tensile system and a better anchorage mechanism. Here on this picture, you'll see that once the fiber becomes engaged, it allows for friction and tension on that anchorage mechanism, allowing for ductility throughout the system. By having such a high tensile and better anchorage mechanism, we're able to control cracks better. And when we compare to any conventional system, you see the tensile capacity, even for our lowest performing fibers, is going to be at least 4 to 5 times greater. You may recognize some of these names. We've worked either directly or indirectly with some of the bigger names in the industry. And there's a reason why they selected our solutions as the main performance-based characteristics to ensure that they can continue to build the systems per specification. We see that all these owners have something in common. They want to build taller racks. They all have nowadays heavier loads. Some areas you may have to account for seismic conditions. And now we're seeing also that some of the industries are looking for even very narrow aisles with very, very small tolerances for floor fluctuation on the flatness. So we also seeing that some operations, especially nowadays, are beginning to introduce more artificial intelligence, higher speed automation, whether it be via AGVs or robotic packaging. But we're seeing this becoming more and more standard for typical industrial warehousing or manufacturing operations. Another thing that owners and engineers have in common is that they're looking for lower production cost, bigger and cheaper, faster project execution, but yet it has to be a longer lasting building. So we're no longer looking for 20 years, it has to be a long-term investment. But what we notice with conventional system compared to when we're talking about socket floors is that they come with a fault system, and this is by design. A typical socket floor is going to have intentional weakened system sections, which limits the load-bearing capacity. By introducing the socket, you're limiting that section for load-bearing capacity. Now, some of the areas I mentioned, especially on the western side of the United States, we see that they require seismic conditions. The demand for such has to be now thicker. And for future expansion and flexibility, it also limits how that building can be resurfaced after a lease is over or a new tenant takes place. In terms of the racking layout or the operational speed, should the building is not ready for a robotic system. So what we're seeing is typically on industrial warehousing, some of the main issues come due to cracks. The more cracks a building has, the more maintenance, the more potential curling. That is going to lead to potential spalling or poor load transfer, racking joints, if you will. I think most of us have walked through an industrial floor where this is a pretty typical picture, pretty typical headache that owners and engineers have to deal with. So when we look again to a typical socket floor, and we see what would be, for example, a typical 8 inches with 18 pounds, what would be the expected premium? We see that it's a pretty common standard nowadays to try to push the joints to every column line, which has been done. We've done it successfully. We've gone over 2 column lines where you only have construction joints. But let's talk a little bit about reducing the thickness while increasing the load-bearing capacity and going 50 feet, 60 feet sockets. That is an additional 7% premium. And this is a study that we've done primarily in the southeast region of the United States and some of the areas in the Greater Toronto area. The premium of 7% is driven primarily by introducing dowel baskets at every socket. You're really not entirely eliminating the main headaches. You're eliminating a substantial amount of potential curls and potential maintenance. But when you go to 120 feet and you're only introducing construction joints, the premium is less by comparison to a typical socket floor. You're only talking about 3-5% premium. And you're increasing the load-bearing capacity because you're also relying on the diamond dowels, in this case for the vertical load transfer. So when we look at operational costs, so the possible operational cost, sometimes some of these items are completely overlooked, either from the initial cost of placement, or for owners that sometimes they just completely overlooked. And there is an equipment failure. Every saw cut is costing money for the operation, whether it be for the resale value or the equipment lifespan. It increases in operational expenses as well. The more maintenance, whether it be on the saw cut floors or on the floors or the equipment, there is a known cost that oftentimes gets overlooked. So what we've done is that we actually looked, we did an analysis to compare conventional systems, the initial placement cost with a return investment, depreciation values, to understand what is really the initial investment versus the long-term cost of a flooring solution. We've noticed and we realized that the delta between saw cuts to 8-inch saw cuts, conventional systems, to a jointless floor, it's around 6% when we look at the initial placement cost of the initial investment. But when you look a year or two, it becomes a pretty break-even cost. But when we're looking at our industrial floor, we're trying to make sure that the investment is going to be good for at least 15, 20 years. But as the building continues to be used, there is a wear and tear maintenance that we have to account for. So by year 14, 15, the cost is going to be exponentially greater by comparing to a typical saw cut floor. So when we talk about long-term investment, a jointless floor is going to have a small premium up front, but it's going to be able to offset the cost of operation as you look forward to the investment. So jointless floor solutions, and the way we identify the best solution is that we can go up to 164 feet with only dry mix steel fibers. There are some limitations by region, given the production. Some of the regions may not be able to fully allocate resources to very large panel sizes. So we are mindful of those things. We can introduce solutions with typical armor joint floors or different solutions with typical wood form with diamond dowels. So these are some of the main reasons why our solutions tend to be the premium go-to system. As you eliminate joints, there is a lower cost. You reduce the maintenance cost, the operational efficiency of the building increases, as well as the resale value. We have a few examples that we're going to be talking toward the end of the presentation, as in why some owners have decided to invest on a premium floor going up front to actually attract better tenants for the future. Also, when we talk about dry mix flooring solutions, jointless floor, it is a transparent system. We rely on having a good quality concrete, relying on good quality products, relying on good expansion joints, and a high performance fibers with a really strong tensile mechanism with a premium anchorage system. We are not relying on any chemicals or on any special sauces. We want to make sure that the engineer and the owner understand the transparency of the system to create a better comfort level. So with any jointless floor, there are 4 key fundamentals: the design, planning, eliminating restraint, and the execution. So when we talk about jointless floor from a design standpoint, we understand that there are 2 different flooring solutions. One that is going to be a spec warehouse building, basically driven by the panel size. In some areas where we're going to have to design for the load bearing capacity, that is going to be a build to suit. Both systems can work in different regions. We participate in both markets, spec warehouse buildings as well as build to suit buildings. With either one of those two designs, however, we need to make sure that we choose the correct materials. In this case, the earlier the better. The earlier the design, the better, because we can start looking very closely to the mix design, give recommendations either for mix improvements or mix testing on the shrinkage, the best performance fiber, whether it be in this case 4D6560 or a better fiber performance, as well as a high quality expansion joints, even expansion joint were to be used. During the planning period, we also need to make sure that the joint selection and the joint location can be identified early on, because we want to allow the shrinkage to take place within the panel itself. We need to make sure that the joint selection is going to allow for two different movements. It is going to allow for the joint to open up and in the east and west direction, but also move in the north and south direction. We need to be able to identify any corners or any intersections to make sure that those details are captured during the planning stages. Also, during the planning is very fundamental that all the parties involved can understand the sequence of the pores. They understand how critical it is to have an aspect ratio not to exceed 1 to 1.5, so that the expectations can be cleared during production. The allowance for the checkerboard is gonna be key to minimize the joint opening between panels. By allowing to pour the first two panels in this case, you would allow these panels to shrink within themselves or within itself, so that the secondary port or third port, you minimize the joint opening between panels. In the past, it has never been a problem, even with larger panel sizes or with smaller panel sizes. The flooring contractor will continue to maximize the production day, depending on the project size and depending on the expectations of the client. Also, during the planning, we need to be mindful that we set production limitations. This may be in terms of the location of the building, in terms of the quality and consistency of the ready-mix supplier. So we need to be mindful of the possible obstacles for concrete sourcing so that we can either increase the panel size or decrease the panel size to make sure that we can overcome any possible production limitation. We also need to be mindful, not every contractor is able to pour 40,000 square feet plus. So depending on the contractor, we need to be able to ensure that the production is going to be met to minimize any additional days on production. Also, we talked briefly about the mix design. Generally speaking, we don't really change much. We give a few recommendations to make sure that it's a well-graded mix with a low shrinkage mix. Historically, most of the ready mix have a really good understanding what the shrinkage on their mixes may be. So this has never so far become a problem for any of our projects. One of the things that may be slightly different is that we try to ensure that you have better control of Mother Nature. So indoor environment can be a key for a good successful project. You want to control temperature, moisture level, consistency on your subgrade, and wet curing practices, which we'll be talking more in detail here in a minute. Again, with the jointless floor, eliminate restraint, all the drains, ensure that you have 2 layers of subgrade, separate them from any areas where you may potentially experience a little bit of restraint or any possible restraint. The do's and don'ts, you can see that not treating the column with a cage of rebar or welded wire mesh is a no-no. So you need to make sure that you have at least a good cage of rebar and compressible material around the column. Around the edges of the walls, you also need to make sure that it's got compressible material and ensure that you can try to eliminate any re-enter corners on the columns as much as possible, such as a diamond detail. The subgrade preparation is key. We need to make sure that your subgrade It doesn't have a lot of highs and lows. That is a well compacted subgrade, so that you don't have to be so concerned with any possible restraints against your subgrade. The preparation of the slip sheet, it's also fundamental, especially if the job is to be tailgated. Best practice from what I've seen some contractors doing from experience is that if you were to tailgate, let's say 120 by 120 panel, the crew is only placing half of the sheet in one area, and as they begin to work their way out, that they can extend the sheet to the remaining, so they don't have to create any tears on the plastic. The joint recommendation. This is also very important to make sure that the vibration and consolidation around the joint is done. Oftentimes, with regular slabs, that's not such a critical point. But with a jointless slab, when you have a steel armor joint or a corrugated steel joint, the consolidation of the joint around the edges and corners is really, really important. There are multiple methods to install the steel joint: pin and weld, or pin and remove, or other methods such as a bracket that they can use. We can address enough how important it is to remove restraint. This is part of the planning, where once a contractor is selected, that these details can be fully understood, that during the execution are not to be overlooked. So either be a drain, a plumbing, a column, that all those areas are fully understood and well taken care of during the detailed planning, to make sure that the execution is followed throughout. The execution also doesn't change between a jointless floor versus a saw cut. Good consolidation with a laser screed and vibration is the only thing that really will take care of the fibers to sit underneath the paste. So the planning on the laser screed doesn't change much. You just need to plan for bigger pores in this case. Some jobs may require shake-on hardeners. Some of them may not, but the process remains the same. Whether you finish the job with behind trowels or power trowels, that process doesn't change. The execution continues to be the same. Critical and key component is the wet curing. We need to make sure that any jointless floor gets cured for a minimum of 14 days, followed by a curing compound. So the curing is key, fundamental, to try to minimize also curling on the edges of your slabs. So we can't stress this enough. So typical applications within a distribution center, highway, and cold storage warehouses. However, there are some areas for either one of those three applications I just mentioned where you may not be able to use a jointless floor. Some where you may see a lot of trenches, a lot of drains on the system, where you will see too many restraint points. That's not so suitable. We are now facing with VNAs more and more. You can do a combination, a hybrid system with rebar, dry mix and rebar, or mesh, or areas where you don't have a perfect aspect ratio. Those are not very suitable applications. Examples where a suitable application, we've done projects like little distribution, where you have racking area, storage areas, and freezer, where the owner understands the importance of minimizing maintenance and having a higher operational speed on their facility. This project oftentimes requires areas where they have to be heavily wet or high moisture levels. Even with steel fiber reinforced concrete, that hasn't represented a problem. This is part of the freezer application, where you can see the separation from the dock and bay to the rest of the floor. Now we have owners that have selected projects to jointless floors for their projects, driven primarily by the robotic systems. In this case, driven primarily by the AGVs and robotic packaging requirements on the facility. Keurig understood that having the flexibility to reallocate the racking system throughout didn't limit the flexibility for long-term growth. They wanted to be able to move the racks and the packaging robotic arms throughout the facility at any given moment. So the floor has the entire flexibility to either rearrange the racking or to reallocate new robotic arms anywhere in the facility. They also wanted to minimize the moving or the racking of robotics as they transition between panel to panel. So the selection of a joint that allowed the support of wheels as they cross each panel was key to minimize that movement. Now, we talked about investors that are willing to attract different tenants. This investor in North Carolina wanted to eliminate, number one, maintenance from previous buildings, but she wanted to also have the flexibility to upsell a system with a robot ready, being able to attract high-end profile customers. This floor was designed to be able to have robotics throughout while minimizing the joint movement between panels or the racking between panels. The same investor also wanted to explore the option to invest on a better pavement system. So they also went ahead and placed a pavement with ceramic steel fibers. This is not a jointless pavement, but it is a typical pavement with regular saw cut options. But they did it just for the long-term durability and fatigue resistance on their pavements. Again, we talked about curing. Here's an example of how critical it is to cure, to try to keep those blankets down. Well, when people look at the expected opening, that's very easy to determine what the opening will be between panels. Once we know what the expected shrinkage may be, we can give the expectation to the client to make sure that it's going to be in line with the requirements for either robotics or the regular speed of operation. We see also Walmart in some areas of South America. They're trying to invest in better systems, and prime example is just Jointless in Costa Rica and some in Mexico. Amazon, we have examples also here in North America where we are trying to eliminate some of those main headaches. Now, while a floor and piles is to be considered also a jointless system, it has just a few different details, but a floor and piles is certainly an option where you can maximize production and eliminate saw cuts. So we have that option. And while we have some limitations on construction and the ability to supply concrete, one thing that you can consider for smaller sizes, let's say 30, 40,000 square feet, is to eliminate entirely all the construction joints. So you don't have any saw cut joints, no construction joints. And the only limitation you have is how much concrete can your ready mix and your floor contractor supply and finish at one given day or continuous pour. For this system, however, we are talking about a hybrid system between ceramics and some type of conventional rebar or welded wire mesh. So this is an example. The owner understood that even a construction joint continues to be a headache. Eventually will become a problem. So they decided to pour a seamless floor on one of the divisions. So this concludes our 45-minute seminar. Should you have any questions or more details, here's my information. You either can call me or you can email me directly. And at this point, we can go ahead and answer any questions you may have.
All right, thanks, Danny. So a couple of questions. Laura asks, why do you use only 4D fibers? Are they better than 3D and 5D? And if yes, why? And I'll come to the second part of this question after you reply.
So we can use a 3D fiber, but we would have to use a much higher, a denser network of fibers, which it becomes cost prohibitive. The reason that we also 4D fiber is, number one, it has a higher tensile capacity with better anchorage mechanism. So we don't need to have 3D with a high fiber dense network when we can work with a 4D fiber for better crack control, more economical solution, and optimal anchorage mechanism. The reason that we don't use 5D is because it's an overkill. Could we use 5D? Yes, we could use 5D, but 5D is going to give a different performance than 4D. 3D and 4D fibers work in a concept called control pullout. 5D doesn't. 5D does a yielding of steel, which primarily is being used on structural applications. Unless your floor is a structural application, such as floor on piles, then at that point, we'll be using a 5D fiber. What is the second?
Perfect. And I'll also just add, I'll put the links up here in just a moment, but some of the differences in the 3D, 4D, and 5D fibers were covered in the previous sessions. So I'll go ahead and post the links to those replays. So if you want to get a little bit more information on the differences on the different fiber classes, that's a great opportunity to check that out. Danny, there was a second part to that question, which was what is the fiber percentage that should be used for jointless floors?
Okay, that's a really good question. I'm assuming the fiber percentage based on the amount of concrete. Is that what is in reference for? Or is that what the question is, Claire?
Well, it says which fiber percentage should be used. So I'm assuming yes, as a percentage of the total concrete section. That's a way I would interpret that.
Okay, so it's not necessarily a percentage. When we are talking initially, we talked about a design based on the panel size and a design based on the load, the demand on the floor. If the design is based on the panel size, we have a minimum dosage rate, which varies on the panel by panel. If we were to talk about 120 feet driven by the panel size, let's assume by a thickness of 7 inches, 120 feet, we'll be talking about a minimum of around 36, 38 pounds per cubic yard, depending on the area and depending on the subgrade. So that will be a minimum dosage. The minimum dosage is going to be based on the required network of fibers using an optimal anchorage with a high tensile capacity. Now, the second part is when it's designed based on a load capacity, there is not a one recipe fits all. It's very project specific because we need to take a look at the modulus of subgrade reaction and the incoming load. What is the demand of the floor? What is the main purpose of that floor to determine what will be the optimum percentage, or in this case, no percentage, pounds per cubic yard or kilograms needed to control those stresses. So it's not necessarily linked to a percentage. It's based on a pounds per cubic yard to meet the demand.
Perfect. The next question, Danny, is for pouring in a checkerboard pattern, what would be the recommendation for the time between adjacent pours?
Very good question. We've seen that for low shrinkage mixes, contractors have been able to come back within 12 to 24 hours, depending on how how big the panel is, how big the project is. It is pretty reasonable to expect a 24-hour period. But if your construction is a small project and doesn't allow for more than 12 hours, 12 hours oftentimes would allow for that initial shrinkage to take place. The longer you wait, the better it is to minimize that opening between panels. But I would say the minimum would be 12 hours between panels.
Perfect. Okay, next question is what methods or software are you using to determine the slab thickness and post-load capacity? So, this person should have attended my last presentation.
I think it would be a really good idea for that person to see the link because we utilize an in-house software. We use a year-line design method to come up with an optimal thickness solution. We used both for serviceability and ultimate state. It may be a good idea. This can be a very lengthy answer if we can follow with that person directly, because that way we don't have to absorb. Because I think that's more specific for a design that I can answer just in 5 minutes. That's a very thorough answer that we probably need to follow up with that person independently.
Sure. And I have posted the two replay links in the second session, which is the technical overview. I do cover a lot of those topics that you just asked in that question there. All right, the next question is, what is the maximum panel area that we can pour jointless in one pour?
The maximum panel area, provided that there is no limitations on concrete availability, they could expect to pour 25,600 square feet on a single pour. That will be one panel. If your crew or if the contractor's crew is large enough where they can allocate production on the same day for an additional panel, that will be basically times two, so 51,000 square feet roughly for two panels. That will be the maximum that you could probably do in one day. I don't know of any contractor that can do more than that by then having to move or allocating two laser screeds, one for each panel, or moving the one to the second panel.
Perfect. And that square footage, just for those of you who will remember from earlier in the slide deck, that's coming from a maximum distance of 164 feet in both directions.
Correct.
All right, next question. What is the maximum aspect ratio of length to width of one panel that you'd recommend?
Ideally, and we're still talking about concrete that is going to shrink. Ideally, we want to keep the aspect ratio 1:1 for best results. We can go up to 1:2 aspect ratio, but we really like to keep it not to exceed 1:1.5. That would be, in my opinion, the extent on a joint, especially when we talk about really large panel sizes. So I hope that answers the question.
Okay, we have another question. Is there a recommended value for concrete shrinkage?
Yes. Again, it depends on how large of an opening or how large of a panel size you're looking to cast. If we say you want to keep a pretty the sweet spot, let's assume is 120 for your production, 120 feet that is by 120 feet. I would recommend a shrinkage rate not to exceed 0.03%. That way you can really minimize the joint opening between panels. Now, if you're working with a mix design that exceeds that percentage shrinkage, then you really need to start thinking about what kind of steel joint are you using to mitigate that opening between panels. If you use a straight joint, maybe having a low shrinkage will be best. If you're using a joint where the opening becomes not as critical because you're mitigating it with a joint that is going to support the wheel traffic better, then you can work with a mix that is going to have a larger percentage on shrinkage.
Okay, perfect. Well, that is the last of the questions that I have in the chat. Oh, we have a couple others. Can you describe the finishing experience with different joints?
Sure. So when we talk about, for example, a straight joint, a full depth profile or armor edge, tends to be a little bit easier to finish because you don't have the corrugation to consolidate as much. When we talk about, for example, a joint like the ones we showed on the pictures, which is called permanent wave, that seems to work better than the corrugated cosinus from finishing. It's not as tedious for the finishing crew to work with, and it's not as critical to make sure that you don't have as much spillage over to the other panel. That seems to be a little more user-friendly when it comes to a corrugated steel joint.
Okay. Question next is, what shrinkage testing do you do?
So generally speaking, they cast a beam to check the shrinkage. We have a few key partners in Atlanta actually that does this kind of shrinkage test. We can send you the specific for the test and the values that they can attain.
Great. Next question. Do you have experience using this product for aggressive environments such as a garbage transfer station?
Very, very good question. Yes, we actually, Beckard itself. We did an expansion in Arkansas, which is we are a steel manufacturing company, and it's very similar, not entirely the same. It doesn't have we don't have front loaders, but the abuse of the slabs are similar to a transfer station. We used a jointless floor for the same purpose of a transfer station, that is to eliminate the maintenance on the saw cuts. We used steel joints to protect the joints for long-term maintenance. So whether it be a steel manufacturing or a transfer station, the use of a jointless floor is going to be far better than the consideration of a saw cut floor for that type of application.
Perfect. Let's see. Any experience with type K cement? Can the size of the pour be increased?
So that's a good question. We have experienced working with type K cement. It is a value that, unfortunately, this zero shrinkage in our software, it can be implemented. We can use the high concrete strength that historically is being provided by type K solutions. Our software limits us to go 164, our tool limits us to go up to 164 feet. That is the maximum. We believe that for anything greater than 164 feet, whether it be plain cement or type K cement, we have to introduce some type of continuous reinforcement. We have not done anything greater than 164 feet with type K cement or regular Portland cement. That would be to the maximum that our expertise would allow us to go. If you wanted to go over that, let's assume 300 feet, 400 feet, at that point we can introduce a hybrid system, a combi system, dry mix plus rebar or mesh, or dry mix plus PT. At that point, a PT post-tension solution may be more feasible to exceed those really long pours that you may be looking for.
Okay, and tacking on to this, I'm going to jump ahead a question here. Is there a fiber dosage recommendation for type K floors?
Again, the type of concrete used is going to be a relation between what type of solution are we looking for. Are we looking for a solution that is going to be driven by the loading criteria, or a solution that is going to be driven by the length of the panel? If it is driven by the loading criteria, then the type K cement would only be able to benefit us on the concrete strength, higher concrete strength values. So that may be a lower dosage. What that dosage may be, I don't know, because it depends on the loads and it depends on the subgrade. However, if it is a design that is driven by the panel size with type K cement, the dosage is going to be based on the maximum panel size and not driven by the zero net shrinkage of what is to be expected, zero net shrinkage on the type K cement. So again, one doesn't fit all. I can't answer one specifically because we would have to evaluate every solution differently.
Yeah, and just tacking on to that, I'll add, that's part of the services that we offer is that we do try to optimize every project based on its specific details and parameters. So, re-emphasizing what Danny's saying, we really don't like to just say a blanket dosage will always work. Okay, next question. Ignatius is asking to talk about that. Great, we'll follow up. Do you have experience using this in food and consumer product environments where a clean environment is important?
Yes. So one of the examples that we showed for Keurig and Dr. Pepper, that is a food and service industry, and as well as a little distribution that is that is a warehouse that storage foods, food and frozen food. So applications, whether it be for industrial beverage, food and beverage, or typical industrial warehouse for just storing anything else, the solution is the same. It can meet the requirements for either industry. So yes, we do have experience in the food and beverage industry. We have a few examples, as a matter of fact, for chicken manufacturing plants, where our solution was used to minimize the openings or the saw cuts or the maintenance to cure the joints as a plant wasn't used.
Perfect. Next question is asking about if there is a maximum dosage recommendation.
Oh, that's a really good question. Yes, it would be. There is a point where the solution with a maximum dosage doesn't become cost effective anymore. So if a dosage exceeds, I would say, 32 kilograms per cubic meter, at that point we need to start reevaluating what would be the better thickness to make sure that we get the better finishing results. So there is a correlation between thickness and dosage to be able to come up with the most optimized and cost-effective solution while allowing the contractor to have good finishing results.
You know, we can tell that you're up in Canada most of the time, Danny. For those of us who don't use kilograms, that's about 54 or 55 pounds per cubic yard.
Thank you, Claire.
All right, perfect. Well, we are right at time. So if you do have any other questions, please do email Danny, or we can leave the chat open for another minute or so here if you'd like to get your question in, and we can follow back up with you later. But I do want to respect everyone's time. I really want to thank you, Danny. Round of applause. Thank you so much for a really wonderful presentation. I want to thank all of you for joining today. I do see one other comment I'll just share. Someone says, I can agree with Danny for food industries. I've used steel fibers in freezer slabs and have heard of no problems. So that's a perfect example. Thank you for that. Okay, well, thank you again, everyone. I appreciate your time. Have a wonderful rest of the day.
Thank you, everybody.